Let's do an example of kind of analyzing a hyperbola, breaking down everything we find out about it from some given information. And sort of a game, a way to do this is if you're not provided with the formula, you're just given some points per se. You want to find the box that generates the asymptotes. So maybe you're going to plot these points and you're going to have to figure out those A, B, and C values. And then you're going to use that to graph the hyperbola and identify the key parts: vertices, center, transverse axis, asymptotes, and then the general formula. Graph paper really can make this quite a bit easier to do, but I'm going to do it without. So let's have an example. For our first example, we're going to look at a hyperbola that's centered at 0, 0, has a focus of 3, 0, and a vertex at negative 2, 0. So let's see, I see 3 is the biggest number there, so I'm just going to give myself a 3 by 3 grid and hope that it's big enough. I'm going to try and make it reasonably accurate here. I may even give myself a little bit of extra room so that I can go further in any other direction if I need to. Okay, so now let's put those points in. Okay, 0, 0 is my center right at the origin. Our first focus is at 3, 0. And I haven't said it explicitly out loud yet, but as with all of these conics, you're going to see that there's a symmetry to them. So if you know one focus and you know the center, you also know the second focus and the center. So I'm going to label this. This is a focus. I'm not going to label the center. My vertex, negative 2, 0 over here, I'm going to label that as well. That's a vertex. Okay, so there's a symmetry with both vertices and foci around the center. So let's talk vertices first. I have the left one at negative 2, 0, so I must have one over here at positive 2, 0. There's my second vertex. And then I know the right focus over there at 3, 0, so I must have another focus in the same location on the left side at negative 3, 0. Okay, so what values do I know? Well, I know the distance from the center to the vertex. We call that A. And from here, let's go ahead and write down that, hey, we just found out that A is equal to 2. That's easy enough. And now the center to focus in red there, that's our C value. And we just found out that C is equal to 3. It doesn't matter which way you do this, to the left or to the right, because we're measuring distances, and symmetry will give us the same distance there. And so now what do we need? We need to find our B value. And to find the B value, we have to exploit this triangle. Well, I'm going to draw it over here to the left to find B. I'm going to draw it over here to the right because I don't want to mess up the good stuff that I have. Well, I know that my center to my vertex, A is equal to 2. And then I know that I'm going to have some vertical distance here to generate the box, and that's going to be B. And don't know what that is yet. Could be long. This picture may or may not be to scale. Could be long, could be shorter. But I know that the distance between these two, the hypotenuse of a right triangle, so to speak, is going to be the distance from the center to the focus. C is equal to 3. So Pythagorean theorem here gives us A squared plus B squared equals C squared. That gives us 2 squared plus B squared equals 3 squared. Let's subtract 4. Okay, 4 plus B squared equals 9. Subtract 4 from both sides. Get B squared equals 5. B is equal to this plus or minus the square root of 5, but we're measuring distances here. So we're going to say that our B value is square root 5. And just to help us graph it, the decimal approximation of root 5 is 2.2. So I'll go ahead over here to my picture and say 2.2. That means I must have a point slightly above 2 and then slightly below 2 in the negative direction. And this will give us our B value there. I've drawn in both of them. I guess I probably shouldn't. Oh no, that didn't seem the best, but we could fix it. And we'll draw in just one B value there. Okay, so now we have enough information to generate our box. So let's generate our box here. All right, so the boxes go through these. They're not, well, these two are vertices on the x-axis. and they go up to that B height, and then they go across through those, I'm not going to call them vertices. They don't really have a name, at least not that I know of. All right, so now we've got our box. And from a box, we can generate asymptotes. We just have to go diagonally through them. And since we're symmetric around the origin, it's going to go through the origin. I'm going to get an asymptote that way. And then I'm going to get an asymptote this way. All right, so what else can we do? We've got well, I guess we should probably at this point graph our hyperbola. We know that the vertices and the foci are right there. And so I can go ahead and open my hyperbola from the vertices, and it'll just kind of approach those asymptotes. And we've done not a half bad job of this thing. That's a pretty good picture. So what can we just straight away identify from the graph? Well, we know the center, and I'm going to bother to rewrite it. I know it's written above, but we're just going to take a minute and write it. We know both vertices, -2, 0, and 2, 0. And we know the foci, -3, 0, and 3, 0. What else could we identify from there? We could identify the transverse axis, the line that goes between the vertices. The transverse axis in yellow here, a little hard to see, apology, but that's the x-axis there. And what is the equation for the x-axis? The equation for the x-axis is y is equal to 0. So straight away, we can identify that. Can we do the equation, the general equation? Well, we know for a hyperbola that opens to the left and right, it's of the form x squared over a squared minus y squared over b squared equals to 1. And we know all these values for a and b, so substituting those in, x squared over a is 2 squared minus y squared over b, which is root 5 quantity squared, equals 1, gives us the general equation for this. Particular hyperbola is x squared over 4 minus y squared over 5 equals to 1. And that's not so bad either. So far we've done quite a few things. We've come up with the equation. We've identified all the kind of key parts from the graph. The next thing we want to ask ourselves are, what about these guys? What about our asymptotes? They pretty well define this thing, so they seem pretty important. Let's see if we can figure those out. So keep that, well, we'll redraw the picture over here. So to real quick redraw, we're just going to focus the picture on the asymptotes here. So 1, 2, 3 vertical, 1, 2, 3 horizontal, and we've got 2.2 at root 5 there, and then over to, what was it, 2, there we are. There's our box, there's our vertex, and then our box goes over like that. And imagine it's perfectly symmetrical and whatnot. So how are we going to find the asymptotes? Asymptotes. Well, so asymptotes are lines. And what is a line? Y equals mx plus b. Right? That's the final format. That's not the important formula to know here. The important formula is y minus y1 equals m times x minus x1. If you're ever looking to find a line, this one will always work, with the notable exception of vertical lines, but don't worry about that. Okay, so, or you could pause and think about why I said that. To use this formula, we need to know two things. We need to know the slope, and we need to know a point, notably x1, y1 notationally. All right, so what we're going to do is we're going to find the slope from our box. What we're going to do is we're going to say from the center, give us a starting point. Conveniently, we'll use the center. The slope is, well, what is slope? Slope is rise over run. So rise, the vertical change, over run, the horizontal change. So we want to know from the center, the slope is rise over run to the, quote, corner. And what do we mean by the corner? Well, the corner is going to be defined by A equals 2 and B equals root 5, which we approximated with 2.2, but we're going to use the exact value when we're doing this calculation. Okay, so rise over run. To find the rise over run to the corner, we're going to use A and B, because those two things define our vertical change and our horizontal change respectively. So our formula for this one, slope m is equal to rise over run. So rise is going to be, well, how much does it rise? Well, it rises root 5. How much does it run? It runs 2. So our slope is, it goes up and over. So positive in both directions, root 5 over 2. So what do we now need? So now we need to take this and say, all right, we know our slope. So I'll fill in our slope over here. Our slope is root 5 over 2. What point do we want to use? Well, you can use any point you want. You could use the corner point here. I guess I didn't draw my asymptotes, and I should have, shouldn't I have? There we go. Let's draw our asymptotes now. So you could use the corner of the box, but that's going to be kind of an ugly point, 2 comma root 5. Why don't we just stick with the nicest point that this line goes through? 0, 0. So I'm going to use 0, comma 0. And so to come up with the equation of this line, the equation of, you know what, let's label this asymptote L1, and we'll label this one over here L2. So to come up with the equation, this is the slope for L1, so m sub L1 is slope for L1. So the equation of asymptote L1 is going to be y minus y1 equals m times x minus x1. And here we just calculated our m as root 5 over 2. And our point is 0, comma 0. So putting all that together, we got y minus the 0, the y coordinate of our point, is equal to m, which is root 5 over 2, times x minus the x coordinate of our point, so x minus 0. And then distributing that through, you would have just y equals, because minus 0 doesn't change it, and root 5 over 2 times x is root 5 over 2 times x, and then minus 0. So the equation of L1, our first asymptote, is root 2, or y equals root 5 over 2. And so let's see the other line. The other asymptote, let's call this L2 over there. So what is our slope here? Well, here our slope is rise. So what do you rise? You rise in the direction of B. So you rise root 5 over run. Well, what's the change in the horizontal direction? Well, so looking over here at our picture, I'll use this red pen here. I'm going to erase what I just write. But the rise, you would actually rise vertically in the y direction, but then you would run negatively in the x direction to get to your next point. So our run value is actually going to be negative. Run is in the a direction, so it's going to be negative 2. A positive number divided by a negative number is just an overall negative fraction. So negative root 5 over 2 is our slope for this one. And the math is very, very similar, and I encourage you to do it. Y equals 0 times your slope, negative 5 over negative square root of negative root 5 over 2 times x minus 0. And then we get y equals negative root 5 all over 2 times x is our equation of our asymptote for L2. Well, we've done it. I don't think there's anything else we can find out about this particular hyperbola. We know the equation, we know the equation of its asymptotes, we know its transverse axis and all of the points. So we'll stop this example and we'll do another one shortly.